Hello, welcome to this channel. In this video, I will show you how to find out derivative of exponential tan x from first principle. Or you can also say that derivative of exponential tan x from definition. Definition means from the definition of derivative. For this, what you need to do is, suppose the given function exponential tan x is y is equal to exponential tan x. Here x is variable and let this be equation 1, and also suppose del x is equal to small change in value of x, or you can say small increment in x, and del y is small change in value of y. Del y occurs due to change in value of x, that is del x. Then you can write equation 1 as y plus del y is equal to exponential tan of x plus del x. Let it be equation 2. Now what you have to do is subtract equation 1 from equation 2 so that we get the expression in terms of del y, change in value of y. First of all, let me remind you that if you don't have any idea about first principle of finding derivative, then you can watch the video by clicking on that I button, or the video link is given in the description. Please check the description. Now subtract equation 1 from equation 2, then you get, first of all, write the left hand side from equation 2, that is y plus del y and minus y, that equals exponential tan x plus del x minus tan x. Y cancels out, then you are left with del y is equal to exponential x plus del x minus exponential tan x, exponential tan x plus del x minus exponential tan x. Okay, to find the derivative of y with y or given function with respect to its variable means to find out the change in the value of the function with respect to change in its variable. So for that you have to divide given expression by del x, that is so that you get del y by del x is equal to exponential tan x plus del x minus exponential tan x, the whole divided by del x. Now what you need to do is, so to find the derivative, you have to check on the value of x, that is change in value of x is very small. That means the value of del x is approaching to 0, or this is very equal to 0, very close to 0. So for that you have to take limit as del x tends to 0, so that limit del x tends to 0, del y by del x is equal to del x limit del x tends to 0 exponential tan x plus del x minus exponential tan x whole divided by del x. Please highlight this. The terms inside the bracket represents the first principle of derivative. Now derivative of y with respect to x is given as dy by dx. Derivative of y with respect to x is denoted by dy by dx, and this equals limit del x tends to 0 del y by del x. And from the highlighted bracket you can insert the value of limit del x tends to 0 del y by del x as limit del x tends to 0 exponential tan of x plus del x minus exponential tan x whole divided by del x. Let this be equation 3. Here we have to insert suppose a few things. For example, let's insert y tan x is equal to u, and tan of x plus del x is equal to u plus k. K here, as del x represents change in value of x, k represents change in value of u, so that k is equal to tan x plus del x minus u, and if you insert the value of u, then you get k is equal to tan of x plus del x minus tan of x. And k represents small change in value of u. So as del x tends to 0, k tends to 0. If you put del x 0 here, then tan x minus tan x gives you k is equal to 0. So as del x tends to 0, k tends to 0. Now let's insert all of these values in equation 3. Then you get dy by dx is equal to limit k tends to 0, limit k tends to 0, exponential u plus k minus exponential u divided by k times limit del x tends to 0, k divided by del x. From first factor, you can take common u exponential u out of the limit. So limit k tends to 0, exponential u times exponential k minus 1 whole divided by k into multiplied by limit del x tends to 0. Now you have to insert the value of k here, and k is tan of x plus del x minus tan x whole divided by del x. Okay. Now since del exponential u is not function of k, so you can take it out from the limit, so that limit k tends to 0, exponential k minus 1 divided by k multiplied by limit del x tends to 0. Now you can convert a tan in terms of sine and cos. So that tan x plus del x gives you sine x plus del x divided by cos x plus del x minus sine x divided by cos x whole divided by del x is there. And this term gives you, this is a standard formula for limit of exponential x or exponential k, and this equals 1. Let's use this value. And in these two terms, you can take LCM cos x and cos of x plus del x. In new page, we can write dy by dx is equal to exponential u, and 1 is the value of limit k tends to 0, exponential k minus 1 by k, and remaining factors are limit del x tends to 0, and after taking the LCM of cos x and cos x plus del x, you get sin x plus del x minus sin x plus del x times cos x minus sin x times cos x plus del x whole divided by del x times cos x plus del x. And you can insert the value of u there, so that you get exponential tan x. Now cos x is not a function of del x, so you can take it out from the limit, and in cos x plus del x you can use the value of del x as 0, so that you get 1 by cos x times cos x plus 0 out of the limit, and the remaining factor you can write, the remaining factor can be written as limit del x tends to 0 sin x plus del x cos x minus sin x times cos x plus del x divided by del x, and this equals exponential tan x whole divided by, this gives you cos square x, limit del x tends to 0, del x is there, and in upper part you can see sin x plus del x cos x minus sin x cos x plus del x is in the form of sin x plus del x minus x. This is actually the relation of sin A minus B, which gives you sin A cos B minus sin B cos A. You can use this relation. Now in next line, what you can write is exponential tan x divided by cos square x, and limit del x tends to 0, x cancels out inside sine, so you are left with sine del x by del x. Okay, and this gives you 1. This is standard formula for the limit of sine del x. You know, limit theta tends to 0, sine theta by theta is equal to 1. This is a standard relation for the limit of sine theta. You have to remember this. Okay, this is standard formula, and we are using this standard formula here. Now you are left with exponential tan x whole divided by cos square x. So the final, our derivative of exponential tan x is equal to sec square. 1 by cos square is equal to sec square times exponential tan x is there. So derivative of exponential tan x with respect to x is equal to sec square x times exponential tan x. Now as a homework, I am giving you this function exponential sine x. You have to find the derivative of exponential sine x from first principle. Please try this, and let me give you the answer as well. The derivative of exponential sine x with respect to x is equal to, you will find cos x times exponential sine x. You have to get cos x times exponential sine x. Please try this for an exercise. This much in this video.